Have you ever wondered what the difference is between a cyclone, hurricane, and typhoon? Are they the same or completely different storms? Well, grab your raincoat and your detective hat, because we're about to embark on a whirlwind tour of these swirling vortices of awfulness. You might be surprised at what we discover along the way. So first off, let's set the stage with a dramatic flair. Picture this: the sky is dark and stormy. The wind is howling and the waves are crashing. There's this big spinning thing out there in the ocean that looks like it could blow your house down. Now, you might think that this is the plot of a horror movie, but it's actually just a tropical weather system doing its thing. But wait, before you start Googling doomsday scenarios, let's take a step back and define our terms. What exactly is a tropical weather system anyway? Well, it's not just a random collection of clouds and wind. A tropical weather system is a low-pressure area that forms over warm ocean water. As the air rises rapidly within this system, it cools and condenses, forming clouds, and also causing even more vapor to get sucked up into the center, and bam, you've got yourself a storm. Okay, so now that we've got that out of the way, let's dive into the nitty-gritty. What's the real difference between a cyclone, a hurricane, and a typhoon? Are they really just a bunch of hot air? No pun intended. Well, believe it or not, the difference between these three is all about location, location, location. That's right, these swirling vortexes of awfulness are actually the same type of storm, but they get different names depending on where they form. Let me show you what I mean. Here's a map of the world with three important lines of latitude: the equator, which is the line that runs around the middle of the Earth, and then two lines of latitude that are 5 degrees north and south of those subtropical ridges. These lines of latitude are important because they help us define the different regions of the ocean where these storms form. Now, when a storm forms in the Indian Ocean between the equator and 5 degrees south latitude, we call it a cyclone. This is the part of the world where most cyclones form. They tend to occur during the northern hemisphere winter, between April and December. Now, let's imagine the same storm forming in the North Atlantic Ocean, between the equator and 5 degrees north latitude. In this case, we call it a hurricane. And it's the same for the western North Pacific Ocean. If a storm forms in the same region, it's also called a hurricane. Finally, if the same storm occurs in the eastern North Pacific Ocean, but just a bit further north between 5 and 20 degrees north latitude, we call it a typhoon. So basically, the only real difference between these three types of storms is their location. It's kind of like how snow is just frozen water. Even though it looks pretty different from liquid water, just depends on the temperature. Now, that doesn't mean that these storms are all the same. In terms of intensity and potential for damage, they can all be pretty serious. But it does mean that we don't need to panic every time we hear about a cyclone, hurricane, or typhoon. Just remember that these are all just different names for the same type of storm. We're going to take a look at some examples of each type of storm and see the different effects they have had on the communities they hit. We'll also talk about some of the challenges that come with predicting and preparing for these storms. And we'll explore some of the amazing technology that scientists use to track them. But first, let's head over to India, where we'll start our journey with the cyclone. A cyclone is a type of tropical weather system that occurs in the Indian Ocean and the South Pacific Ocean. These storms can be very powerful with high winds and heavy rainfall, which can cause flooding and landslides. One of the most devastating cyclones in recent history was Cyclone Fani, which hit the eastern state of India in May of 2019. This category for storm had maximum sustained wind speeds of 180 kilometers per hour and caused widespread damage to homes, roads, and infrastructure. Fortunately, due to effective disaster management strategies, the loss of life was relatively low. But the economic impact was significant, with thousands of houses destroyed and agricultural crops flattened. Moving westward across the Indian Ocean, we arrive in the Atlantic Ocean, where we encounter the hurricane. A hurricane is the same type of storm as a cyclone, just further north. Maximum sustained wind speed criteria defines the category of a hurricane. Category 1 has speeds of 74 to 95 miles per hour, while Category 5 has speeds of more than 157 miles per hour. One of the most infamous hurricanes in history was Hurricane Katrina, which struck the Gulf Coast of the United States in August of 2005. The storm surge from the Category 3 hurricane caused massive flooding in New Orleans, leading to catastrophic damage and displacement of hundreds of thousands of people. The human toll of the disaster was immense, with over 1,800 lives lost and thousands more injured or displaced. Finally, let's head over to the northwestern Pacific Ocean, where we meet the typhoon. A typhoon is essentially the same as a hurricane, just a little further east. One of the strongest typhoons in recorded history was Typhoon Haiyan, which hit the Philippines in November of 2013. The Category 5 storm had sustained wind speeds of 195 miles per hour and caused massive devastation in the central Philippines. Entire villages were wiped off the map, and more than 6,000 people lost their lives. So there you have it, 3 different names for the same type of storm depending on where it occurs. Now that we understand the basics, let's take a deeper look at what these storms have in common and how they form. First, these storms are all tropical weather systems, which means they form over warm ocean waters. The surface temperature of the ocean in the areas where these storms form is typically around 26.5 degrees Celsius or 80 degrees Fahrenheit. The air above this warm water rises as it cools. It forms clouds and also condenses, which forms the characteristic spiraling shape of these storms. The storms are all characterized by a low-pressure center, strong winds, and heavy rainfall. They also have something called a well-mixed eye wall, which is the area of the storm with the strongest winds and heaviest rainfall. Inside the eye wall is the eye, which is a relatively calm area of low pressure. These storms can cause a range of problems, including high winds, heavy rainfall, storm surge, and flooding. High winds can cause structural damage to buildings and other structures. Heavy rainfall can lead to flooding and landslides. Storm surge is a rise in sea level that occurs as a result of the winds pushing seawater towards the shore. This can cause coastal flooding and erosion. Preparing for and recovering from the impact of these storms can be challenging. Early warning systems are in place to give people time to prepare and evacuate if necessary. However, communication infrastructure can be damaged by the storms, making it difficult to disseminate information. Now let's talk about the damage that these storms can cause. The damage from these storms can be both economic and environmental. The economic impact can include damage to property and infrastructure, loss of life, and business interruption. Environmental impacts can include coastal erosion, damage to coral reefs and other marine ecosystems, and changes to river flows and water quality. Take a look at the images and videos of the aftermath of these storms. You can see the devastation they can cause. Homes and buildings can be completely destroyed. Roads and bridges can be washed away, and entire communities can be left without power or access to clean water. Finally, let's talk about some of the amazing technology that's used to track and predict these storms. Meteorologists use a variety of tools to track and predict these storms, including satellites, radar, and computer models. Satellites provide imagery of the storms, allowing meteorologists to monitor their development and movement. Radar provides information on the intensity and location of precipitation within the storms. Computer models use mathematical equations to simulate the behavior of the atmosphere and predict the future behavior of the storms. This technology allows meteorologists to issue timely and accurate forecasts, which can help people prepare and evacuate if necessary. In addition to the technology used to track and predict these storms, there's also a lot of research being done to better understand them. Researchers are studying the factors that contribute to the formation and intensification of these storms in order to improve forecasts and predictions. They're also studying the impacts of climate change on these storms, which are expected to become more severe and more frequent in the future. It's hard to say exactly why some storms intensify more quickly than others, but researchers are working on understanding the process better. This knowledge will allow us to better predict the behavior of future storms and potentially mitigate their impacts. Well, there you have it, folks. From cyclones to hurricanes to typhoons, these powerful storms may have different names. But they're all part of the same wild weather phenomenon. And while we may not be able to control the weather, we can control how we prepare for it. So, next time you hear about a brewing storm, don't panic. Just remember that knowledge is power, and with a little bit of info, you'll be able to weather any storm that comes your way. If you found this video helpful, please consider liking it and subscribing for more fun and educational content. Thanks for watching, and stay safe.